Hi everyone! Several people in class have mentioned that they don't actually have that much experience with mathematical typesetting, so I thought I'd make a short video covering some of the basics. In our course, we're going to be using HackMD, which is this website I've pulled up here. It's a collaborative Markdown editing environment with math rendering support. But before we get started with that, let's make a couple of distinctions. So Markdown is a lightweight markup language for creating formatted text using a plain text editor. So you might be wondering why you'd want to use a plain text editor when you could use something like Microsoft Word instead, which has a built-in equation editor, which is reasonably powerful now, though still not quite fully featured. Well, one of the big reasons is portability. Once you've written something in plain text, you can copy it and move it around as you please. Now, many of you will have heard of LaTeX. LaTeX is a full system for document preparation and typesetting that was created several decades ago by Donald Knuth and Leslie Lamport, and it's actually a Turing-complete programming language. Though most people use it as something more akin to a markup language, you can actually write full programs in it, and some of the templates that you see in LaTeX documents make use of that. Now, for any professional math or computer science articles that you write, you'll need to make use of LaTeX. But it does take a little bit more time to get started with. So in this course, since we only need the mathematical typesetting feature, we're not going to make use of the full power of LaTeX. Thus, we're going to just use the mathematical typesetting that's available in some flavors of Markdown, including HackMD. Note that the mathematical typesetting syntax is borrowed by HackMD from LaTeX. And so once you learn mathematical typesetting in HackMD, you'll also be able to do it in LaTeX, though of course the document preparation in LaTeX will require other boilerplate. So let's get started. I have created a HackMD document here, and so you'll note that when you go to the link, it's a blank page right now since I haven't written anything. But if you go to edit, then you'll be able to see, hopefully it comes up, yeah. So that's a couple different modes. One of them is this editing only mode, source code only mode, which allows for collaborative editing. One is this preview only mode, which is what we saw earlier. And often it's easier to start with this side-by-side view, so you can see what you're writing, your writing looks like in the display while you're writing the source code over on the left. So let's get started. The first thing you'll want to do in a HackMD document is you're just going to write down the title. So this is a HackMD tutorial for MATC58. And once you have a title, you can also give a couple, you can just type text normally. So this is a brief overview of the mathematical typesetting that we're going to be doing. And you can have subheadings. So let's have one subheading being, why not LaTeX? LaTeX is obviously the most fully featured choice for mathematical typesetting. It's a Turing-complete programming language, although most people use it as something closer to a markup language. And we can put in links as well. So let's see. One of the nice things about HackMD is it actually gives you shortcuts to many of the common things you'd want to do in Markdown. So let's create a link here, and we actually need LaTeX to be inside that link. And let's go ahead and link it to this page from the LaTeX project. That'll go here. And you'll see that over here on the right, the link appears in the preview panel. But LaTeX takes longer to learn, so in MATC58, we're just going to use HackMD instead. So let's give another subsection. Let's say HackMD mathematical typesetting. Well, you can go into the equation mode in the same manner as in LaTeX. So let's say we want to typeset a simple equation. For example, e.g., you open up a LaTeX equation by having a start $sign, and you end it with another $sign. So here, if I write something like x squared plus 2x plus 1 is equal to x plus 1 squared is equal to 0. Let me see if I can get that to update properly. There. So you'll see that it's rendered here on the right because we started, and it's everything between the $signs has now been typeset in this way. So what are the various components? So you can have exponents, and that's x, the up caret sign, y. Oh, I misspelled exponents. You can have, let's actually make this a list to show you that. So you can create a list by just having an asterisk here and hitting a space, or you can go up to list symbol here, which also adds in the list. You can add in a list with either numbered or just, oh, I think I made it both numbered and asterisk, bullet pointed. But let's just, let's just go back to a single bullet point. So you can have exponents, you can, let's see, exponents, and what else? Fractions are common, so for that it's just a fraction, let's say x over y. Let's put a colon there. Fractions, what are some other common things? Log and trig functions. So things like you can hit a slash log slash sine of x p squared, and so then it automatically typesets that. Note that if you write just text without that isn't a special operator, that isn't a special name, you get something else instead. So text doesn't works, but LaTeX thinks they're variables. So things like apple tree. Well, unfortunately, that thinks that they're variables, and so it like lumps them all together. If you want to render text, what I usually do is I do slash text, and then you get apple tree typeset the correct way. Some of the other common things that you'll probably use in this class, later on we'll have to start dealing with derivatives, and so there are a couple ways of doing that. So you can have, well, you can use fractions, of course. So, I mean, they're not actually fractions, but something like dx dt. But that's also equal to x prime, so that's just an asterisk, so that's easy. But sometimes you'll also want to use dot notation. So there. So derivatives. And let's see, what are some of the other things that we'll be doing? Fractions, derivatives, log and trig functions, text. Oh, one other useful thing is there's two different modes for displaying equations. So these are inline equations with a single $sign. You also have block equations with double $signs, which doesn't really make a difference for these things. But let's say that we had a sum instead. So sums and limits. So let's say we have the sum from I equal to 0 up through. So the underscore here is a subscript. I should probably mention that. So subscripts x sub 1. And often when you're doing these exponents or subscripts, you may need to do multiple things. So you can you need to put them in curly braces. 1 subscript 1 plus I, for example. But yeah, so you can use a subscript here for the sum, and let's go up to let's see. Let's say that goes up to k, and then let's use n there. And let's say we want to add together 2 to the power of minus n. And let's actually say, let's actually take this limit as n so it goes to infinity of this sum. So what is this sum equal to? Well, this is just the geometric series. So when we're taking this thing here, this is just It starts with 1 plus 1/2 plus 1/4, etc. And so since it's a geometric series, this should just be equal to 2. Okay, I think that's all that we really need. You really need to get started with writing these. All that you really need to get started in order to write math in the LaTeX format in Markdown. Oh yeah, if you put, sorry, one other thing. If you put double dollar signs, this turns into display mode, which is sometimes nicer to read. Double dollar signs and put it on its own line. And it turns into display mode here. So you'll notice that the subscripts and superscripts for the summation and the limit, instead of being to the right, are just now directly underneath and above. There are much fancier things you can do in LaTeX as well. I will not go into all of them today, but let's leave a couple links. So let's see. Let's leave a create another section, useful links. And we already have a link about LaTeX. Let's copy that again. And let's use the other type of list. And let's see, what else? Markdown tutorial. I'm going to link to the GitHub Markdown tutorial since I think that's very well done. But you should note that the GitHub Markdown tutorial doesn't actually include doesn't actually include mathematical typesetting. So let's see, where was my GitHub Markdown? So this here is GitHub's Markdown guide. Let me, just a moment, let's go to Art of Problem Solving, which has a good LaTeX guide. So this has a fairly comprehensive LaTeX guide, and let's see, this is AOPS LaTeX guide. Since that has a nice tutorial for basic things, so let's actually, so Art of Problem Solving has a nice series of tutorials for all the different complicated things you can do using LaTeX, including using symbols. So you might need these for things like alphas, betas, omegas, as well as you can import pictures, and you have all sorts of other math symbols you can also put in. I think that about ends what we need to do for today. Hopefully that was helpful. As I said in class, I do expect you to be able to do mathematical typesetting, and that's one of the best ways of collaborating with your breakout session groups. Though, until you get good at it, you'll probably still be faster at writing by hand. It is still an important skill for you to learn. So thank you very much, and I hope this was helpful.